Hi. Today, we're going to start the first of a series of lectures that's going to teach you about web development. The focus of this stream in particular is ASP.NET Core. We won't be getting that much into HTML, CSS, JavaScript, although it will be used. There are other courses for that. But even if you don't know that very well, I believe you should be able to follow along. If you've lived in the modern world, you've probably noticed it's looking back at records, or even if you have lived 30 years, you'd see that society has drastically changed because of the internet, smartphones, laptops, and other such devices, all of which use websites. In the beginning, what's funny about the internet is that there was a lot of doubt about its success. In 1995, Newsweek even published an article stating that the internet was a fad and it would fail. Boy, were they wrong. In 1995, banks also started to offer their services online for the first time, as well as secure internet protocols started to appear. Furthermore, from 1995 to the year 2000, the .NET bubble started, which is a period of time during which there was a lot of hype about the internet and the economy just boomed because of it, and a lot of companies were adopting internet technologies. Today, the internet's a part of our lives, and with it comes websites, web applications, and a significantly more complex life than the people that lived prior to it. The net knowledge of people because of the existence of the internet is much higher because of how widely accessible it is. The world the boomers grew up in versus the world of today was much simpler. And many of the old timers wouldn't quite understand how things have changed. Some people may want things to go back to how they used to be, but in reality, the internet has changed things and there's no going back. This is a fact of life. This hard reality was faced by Blockbuster going bankrupt. They were approached with the concept of online video stores, and they turned it down. They didn't think it would be a thing. Then Netflix came along and their business went crashing, and Blockbuster went, a large corporation that was everywhere, went bankrupt and fell like the Tower of Babylon. If you have a small business or have tried putting up a site of your own, you've probably heard of WordPress, Wix, and other such applications to help you make putting up your own website simple and quick. But that's not what we're going to be covering today. We want to be all-star developers, right? And in order to do that with ASP.NET Core, I believe that you have to know the answers to the following questions, especially when you're approached by managers or potential clients. These are common questions I've noticed that come up, or you should know the answers to, because it'll make your life and programming career a lot easier. So some of the questions that I believe you should know the answer to are: what is a website? What is a web application and how does it differ from a website? Why use a web application versus a regular application versus a mobile application? Why build your own website when you can utilize something like Wix or WordPress, which will be able to do the same thing as building your own with less work? Why are web developers always switching up technologies and languages? What are the benefits of one technology over another? What does it take to think like a programmer? What makes the programmers different from the general population? How has the way web pages are developed changed over time? How is the way web pages are built going to change in the future? What are the expenses related to hosting a web application? And that's all for now. If you haven't ever asked yourself these questions, you should. Asking the right questions and finding accurate answers in life will make your life a lot easier. Furthermore, as we learn to develop web applications, I'll bring up additional questions that you should know the answers to, which will make your development experience much more pleasurable. Remember, stay engaged. Understanding is a two-way street. I can't know what you don't know or understand unless you ask the questions. In order to succeed or become good at anything, you got to have the 3 Ds. Desire, discipline, and develop. In particular, develop is related to programming. In my opinion, knowledge of how to do things always trumps definitions. However, knowing those definitions and the answers to these questions makes communication and conveying of information and interest stay high later on. So let's get to answering those questions. Firstly, what is a website? A website is a page that you go to that you can't interact with. An example would be a blog without the ability to comment on it. So it is a static page or interrelated set of pages. This leads to our next web application. Next question, what is a web application? A web application or dynamic website is a website page we can interact with. So with a web application, you'll be able to enter in comments for other people to see. You'll be able to log into it. Basically, you can interact with the page. You can make purchases. You can control cameras remotely. You can edit videos. Basically, web applications are applications hosted over the internet in which you have a lot more flexibility. eBay's web application. Yahoo Mail would be a web application. Most sites up today aren't websites, even though the term website might be used interchangeably with web application, but usually they mean web application. A website is essentially just text media. A web application has everything a website has, plus more, the ability to interact with it. Clearly, utilizing web application opens doors. In fact, I'd say web applications are the reason for the majority of small businesses exploding into million-dollar businesses in this day and age. In recent years, you may have heard how the smartphone mobile industry has exploded, and there are more people using mobile devices than laptops or computers. So this leads to our next question. Why use a web application versus a regular application versus a mobile application? Have you ever opened a program and had to wait for a very long time before it opened? The reason for that is because the memory on your computer and your processor was doing complex operations under the hood that took a lot of processing power. The main difference between web applications and regular applications is that web applications distribute the web workload between a computer called the web host, which is not your computer that you're browsing with, and your computer, the computer that you go to that website on. What a web application has access to on your computer is severely limited by your browser. Furthermore, any activities you perform locally are usually double checked by the server to make sure nothing goes wrong or you don't have enter in invalid data. This is in a web application. With regular applications, most of the work is done on your computer. It might communicate with another server, but the purpose of web applications is to have more access to your resources, or in the case of mobile applications, have more access to what your phone has to offer. Furthermore, regular applications and mobile applications usually have access to local files and higher level resources with fewer controls and can cause more damage if they're abused or if it's a malicious program. That last point is arguable, but I won't get into it right now. Also, if regular applications and mobile applications are communicating over different networks and use unique communication methods, they could run into unique problems. They also tend to be limited and tailored towards certain types of devices. Web applications usually have a standardized method of communication or limited by browser version, more so than your hardware, and consequently, you have less complexities to deal with if it's built correctly. However, access to resources and processing power is majorly limited. Furthermore, with web applications, With applications, you have to worry about the different versions used by your different customers and the incompatibilities that might arise from it. With a web application, you just got to upgrade the web application on your servers, and boom, all the users will receive the updated version of whatever when they come to your site. With applications, you might have to deal with people using different versions of the applications in different areas. So there's more overhead cost for a company to provide an application as a service. Consequently, I'd suggest using web applications over the other types of mobile and regular application when computational intensity and graphical power is an issue, and when you're not limited by resources, simply because it's overall, in the long term, it'll be less work for developers, upgrading, and scenarios you may have to compensate for. You might disagree with this. Feel free to throw in your 2 cents or counter arguments. After all, I'm just a person. I'm always learning, just like everyone else. Now, a question I've often been asked by clients and heard from students in classes that I've taken is this: why build a web application from scratch when you can use a framework like Wix, WordPress to build out your site? My answer to that, and I've heard varying answers to this question, is in numerous scenarios, it's actually a good idea to utilize a framework such as Wix or WordPress. Because a lot of the work is already done for you. You don't have to rebuild this stuff. But the minute you hope to integrate it with other systems to automate processes, if the data is not exposed right, or your team is not trained with the proper sets of tools to pull out the data from the databases behind those sites, or you might not even have access to the data behind those sites based on what you're using, a unique set of problems is introduced. Furthermore, when working with WordPress or Wix, creating custom functionality or compensating for unique scenarios might be more complicated or difficult in case they haven't thought of it, because you'll have to implement it, and it might require a lot more bulky code because you have to work around the framework. And something you don't often hear about utilizing frameworks is sometimes the frameworks have limitations. So you'll have a customer come to you with a request, and working with the confines of that framework will make it much more difficult, if not impossible, to implement that requirement without modifying the core code. But if you build it from scratch or with a technology that allows more flexibility, you'll be able to do anything you need. Furthermore, sites that are data-driven, utilized as applications, have a lot of UI interaction, like a game, or have a lot of users using it, and it's on the cloud, might have heavy performance hits as the data grows or the amount of users use it. Or if not, because these are usually server-side CMSs that are provided by these companies, what will happen next is that it'll perform poorly, as well as, since you pay for processing power as well as stuff that's sent out to the people that are using your sites, you might take a heavy financial hit. But you got to also remember, because of the ease of use of WordPress, that it is used by 30% of the internet users today. What I said before about performance and stuff, that might change in the future. But as of today, which is 2019 December, that's how it is, in my opinion. So for small sites like landing pages or e-commerce stores, it might actually be easier to use pre-built modules provided by Wix and WordPress. However, as your needs become more complex and you truly want to utilize the full power of a web application, to say provide a web app page for individual people to remotely control devices in their home, or have a web application that reads other sites and brings in that data and congregates it for other users in a useful way, or scan members of your organization's ID and check it against check their ID against like webcam information and stuff like that. It will be a probably in those scenarios you won't want to use Wix or WordPress because they don't have the functionality to easily provide that for you. The main reason for WordPress and Wix's massive success is that the majority of companies that do utilize them have needs that can be met quickly with them and don't think beyond that. They think of a web page as something simple when it's really an application. Furthermore, it's very intuitive to use, so someone that has never coded before can go in and click around and figure out how to use it if they're semi-computer competent. So in many cases, it's the financial choice to use. So this leads to my next question. Why are web developers always switching up technologies? Why don't they just stick with something like WordPress or Wix if they could provide useful service for the majority of their customers? Well, from what I've seen, technology runs in waves. People bet on a technology or language, and it'll boom, and then they'll find out it's not what they thought, and all of a sudden it'll crash and go out of use. Because they're betting on it based on how it was sold to them, based on a concept rather than actual knowledge. Furthermore, new technologies usually have less you have to learn, so there's more flexibility for how you use it, and you're not going to be criticized for doing something in an inefficient manner because everyone's picking it up while you're picking it up. There's less to learn. And there's more flexibility. What you'll notice as you go from company to company is that they often use the same technology in different ways with different libraries, especially newer technologies that were built, newer systems that were built during the time a new technology was picking up a lot of hype, like Node.js. So they'll use different libraries and build it in different ways, solve different solution problems in different ways. The way of building things is not very standardized, as a lot of times when these developers are building, they're learning a lot of stuff. More often than not, people learn new technologies and they use them in self-defense without a thorough understanding of how it works, and consequently they build systems that are overly complicated to solve a simple problem, or use libraries in ways they weren't meant to be used. But this is okay. You don't have to be a perfectionist in order to create a solution for a problem. Knowledge, in my opinion, to build something, discipline and drive are more important. As long as you know enough to build it, it's okay, because you're learning, right? And we all make mistakes, and it's not a mistake, because it's better to finish something than to try to get it done perfectly. And a lot of large software companies and people that have made a lot of progress don't focus on perfection. I've seen bigger businesses tend to have more flexibility and focus more on creativity rather than perfection. However, good knowledge of the tools and full scope of a language and technologies while implementing a solution using best practices and standard tools will allow you to build it with less difficulties, faster, and more efficient code. So there'll be less code in your solution, and thus later on it'll be easier to maintain. So knowing how to do it right is always useful, but don't let that prevent you from actually building something, because you don't have to build something right? It just helps later on, so you can rebuild it. The key thing is to learn things and become better every day as you do it. Don't be a perfectionist, be someone that gets stuff done. This brings us to the next question. And another point is that using best practices will help you avoid problems, because they're put there for a reason, in order to avoid certain problems that other people have come across. So best practices are built upon the experiences of people that preceded you, that built a lot of systems. So learn from them. Don't recreate the wheel if possible. This brings us to our next question. What are the benefits of one technology/programming language over another? The smart way to determine whether you switch to a new technology is to ask yourself whether utilizing that technology will reduce your team's overall workload and downstream issues. With switching like a programming language comes retraining costs and time. Oftentimes I see a lot of programmers jumping to newer technologies based on hype, and those technologies are sold based on a sales pitch rather than actual benefits. So you got to be careful about that, because I see this commonly happens. And if you are to jump from one language to another without seeing its benefits, it's going to just create more work for you. It doesn't mean it's wrong or it's bad. It just creates more work overall. Furthermore, with new technologies, there is no guarantee that the people training you will teach it in an optimal and correct way. As I said, as new technologies are introduced, there's a lot of flexibility. As the technology matures, people learn how to, they create better practices and better standards that reduce the complexity of creating systems. And there are better tutorials, and the teachers are more experienced. And better teachers, because they've gone through the cycle of teaching again and again. So if you wait a while till there's a lot of support for that technology and a lot of people that have used it, you're more likely to get better training. The newly created systems and frameworks will be more refined, because whenever something's new, usually they have a lot of flaws. This doesn't just apply to programming languages, but also OSs, applications. So usually companies, for the sake of security, wait at least 2 years as a rule of thumb. Not all do. Wait 2 years till it's been tested and used, and then pick it up, because then they'll release patches to solve problems that they overlooked later on. Examples of where this has happened, and you might not have been aware of this, but this has happened on wide scales before. For example, with Bitcoin. Bitcoin actually had major bugs initially when it was created. I think this is prior to it jumping over $100 value per Bitcoin. Now it's worth like, I think 10,000, but it got up to 20,000 at one point. There was a flaw with it, so they had to release a patch. The visa systems, I remember when they were used, initially a lot of taxi drivers would complain because people would use fake visas to pay for their taxi cab, and they couldn't, this is in the past, this is like, I'd say this is about 20 years ago. They'd use the visa to pay for the actual taxi cab drive, and then they would go to verify it, but the actual card would bounce because they were using fake credit card numbers. And this was possible in the past, although this has been rectified today. This was a severely widespread loophole back then. The newer Coca-Cola machines, you know, the ones that have a can, and then you press a button, and then it goes and gets that can. Conveyor belt goes up, it comes out onto the conveyor belt, and then it comes out by the side. So there's a container that's more vertical than horizontal. This is a vertical one. It opens up a door. The Coca-Cola can goes out and drops. What a lot of people were doing when these first came out, because there was a flaw that was widely spread about around those machines, is they would hold the door closed. So then it would try to push out the Coca-Cola can, but when it didn't open the door, it would go up and grab another Coca-Cola can, and then it would come down, and then you let the door go. What this meant is that you get two Coca-Cola cans from that machine, because that was a software programming bug that they didn't think of back then. It was a fail-safe to make sure people got their cola, but people were abusing it. The telephone booth, back in the day when people used to use the coin telephone booths, you could pick up the phone, and I believe on some of them you could play the sounds of pressing the buttons, and it would register as you having pressed them. So usually you'd have to put in a coin, but if you just played the sounds in order to of the buttons being pressed, it would automatically make the phone call for you, rather than having to use a coin to make the phone call. But that's been changed as well. That was fixed. The internet when it first came out was inherently insecure. So what was sent over the internet was plain text, and you could view it all if you were listening in on someone else's connection. there were a lot of security holes, but as of 1994, they started releasing more secure protocols in order to prevent against a lot of the security oversights that this widely used system had. There still are some, but it's gotten a lot better than it used to be. Wireless car locks and garage openers. So initially when these came out, you could actually, if you caught the signal, you could intercept it and replay it. And then you would be able to open other people's garages or open their car. And this is clearly problematic if you use it to start their car, right? Analog cell phones. I remember I knew a Russian guy back in the day when I was in university, and he would actually modify these analog cell phones so that you could use them without actually paying the cell phone provider. Digital cell phones have changed, so you don't have that, it's not as simple anymore. Healthcare systems. There have been a lot of healthcare leaks. I remember, I think it was in 1997, I might have gotten the year wrong, but a medical student was using the UK's healthcare website, and then they found out they could gain access to other customers' accounts by just changing a part of the URL. Retail stores, you might have heard of the Target store leak. I'm not sure if it was the database leak, and a lot of these big retail stores that use databases, not just retail stores, but healthcare companies, etc. And even Yahoo have been having account leaks. I don't know if this is some government propaganda for some upcoming scandal, but yeah, so security with new technologies and the imperfections, I've digressed. The imperfections, a lot of technologies is there when they're relatively new, and it gets refined over time. As people gain more experience in technologies and make the mistakes, the curriculum becomes better and lessons planned and lessons are learned. And you can learn from that without having to run into them yourself. That is why I think it's better to work with more mature technologies rather than to jump on newly created ones. Furthermore, different programming languages have different strengths for different scenarios. For example, languages like MATLAB are better for algorithm and signal processing reasons. Languages like CAD languages, AutoCAD, VHDL, are better for designing circuits and objects. Platforms like Unity are better for creating games. HTML is better for creating website. HTML and CSS are better for creating website graphical interfaces. So when you are picking a new language or technology, ask yourself what your goal is and to choose that language appropriately. As time progresses, newer languages will come along and there will be a lot of hype about them. And sometimes there won't be, but they'll be able to solve problems easily that were a lot of work to solve or code around previously. So keep learning and finding faster, easier ways and better ways to do things, but always know how to use that technology if you want to save yourself time and work. Use it well. This brings me to my next question. What does it take to think like a programmer, or what makes programmers different from the general population? Programming, in my opinion, is a new language that is simpler to learn than most spoken languages. However, it does take grunt work in order to learn it. You can't just learn the particularities of a language without using it as well as studying it in depth. The same applies more so to programming languages since they tend to be more logical with fewer contradictions. It doesn't take much to learn. In fact, I encourage you to try to learn new languages on your own. You learn through doing, especially with languages. Start small and then work to something bigger. However, in the process, what you learn is that you will build systems only to realize things you could have done better in the aftermath. This is where experience comes into play. Thus, while you can learn a programming language through trial and error, and I do suggest it, just like you can with spoken languages, having a good mentor that is knowledgeable and has made mistakes so that you can learn from them rather than recreating the wheel will save you a lot of time and sweat. Furthermore, I believe it is beneficial to learn it as a whole on a high level before delving in and learning each of the language's particularities. Because when you know the full scope of a language, you're not going to rebuild the wheel, the language and the framework. Because a lot of times I see people coding out functionality that there already exists a library for in the .NET framework. So don't recreate the wheel. If you want to eat a more smoother experience with that new language. There's resistance to this view since programming as a science has been taught in schools and is only 50 years old at most and has changed vastly since inception. Many of the older programmers learned the language through older books and experiences they picked up going from job to job and looking at the implementations at other companies. Consequently, if you look at many custom systems and how are they built at different companies, you'll notice differences in their implementations, programming patterns, and approaches to solving similar problems, and they differ based on how they implemented it. Furthermore, you will notice issues in design that tend to appear again and again because people recreated the wheel. With the advent of software engineering, there has been patchwork effort to rectify this. However, despite this, the majority of large systems in use are built from antiquity, were not created by computer science or software engineering graduates. I want you to remember that. But graduates of degrees predating them, people who learn from curriculums vastly different from what we had today. So if the software engineers and computer science graduates aren't the ones producing the majority of systems, I think it's a clear example of why anyone can become a programmer. It just takes that discipline and drive. Furthermore, in my opinion, many programmers and technicians love to overcomplicate things unnecessarily, so they'll put in a vastly more complex solution than they need to be. But in reality, you just got to solve the problem, and then you could add things on later. You don't have to solve the world when building something. You just got to solve the problem that will result in time savings, lessen workload, or profits. The industry is perfused with many people that will use your ignorance to sell you on false concepts and ideas, or people that think that they know everything rather than seeing what you know and filling in the gaps. This is why it's important to continuously learn, because you're competing. But it's better to collaborate than to compete, because that's how the world runs. Collaboration. As alone, you can't really do much, but as a group, if you work efficiently together, you'll get so much more done. The government is aware of these loopholes in a lot of languages and new things, so Snowden's whistleblower controversy is an example of this. But we won't get into that because this was about languages. So some languages have inherent flaws that allow them to be exploited. So the next question I want to answer is, and you may be asked, is how website design has changed over time. Well, in short, it's gotten simpler. Older web development languages required something called data sanitization. You had to be very careful and were susceptible to several security vulnerabilities like cross-site scripting, SQL injection, directory traversal, web page defacing, privilege escalation, sniffing, remote code execution, overposting attacks, JavaScript hacks, and more. I'll have another video or a video stream where we will actually go into that, but that's not the thing. The takeaway is that older technologies used to have a lot of security flaws and older implementations. In fact, in order to build out websites without these issues, with these older technologies, you'd have to have knowledge of them and compensate for them. This isn't just web development languages, but older programming languages in general. What protected a lot of infrastructures in the past was the fact that the general population was ignorant to how the technology worked, and in reality, they were using systems that were highly unprotected. Even Microsoft is guilty of this. IAS, which is a application that's used to host websites, And what I mean by that is it's what runs websites, basically. So if you're running a website, you need this running in order to allow people to access it. Prior to version 4, I believe, it might have been a different version if I'm remembering correctly, but it was you were able to remotely execute codes on the server, and I also think it was vulnerable to directory traversal, but I can't remember exactly. I may be misremembering that. So this was a web server that was used by many big businesses and enterprise scale companies. Big businesses like banks, insurance companies, software companies. Yeah, so everyone's guilty of using this. I chose Microsoft today because I've often seen systems implemented with it overcomplicated. Furthermore, there are a lot of misleading educational resources out there, as well as high quality resources in existence. The key is to know the difference. People learned the technology or built things from scratch unnecessarily that were available out of the box. But if you know how to use it properly, you can build things faster and not run into as many issues. Note that Microsoft has several web frameworks currently that vary in their use, the newest one being Blazor. I'll be teaching you server-side .asp.NET Core MVC coding that uses C#. The reason why I'm not using Blazor is because it doesn't run correctly currently with older browsers and only newer ones, because the older browsers don't have assembly, the ability to run WebAssembly. So knowing this, where is web development heading in the future? I believe as time goes on, web development languages will converge into a common standard or language, and one major dominating language will survive. Most applications and mobile applications will be a web-based platform that can also run without a connection to the internet, so it will be saved on your computer. But it'll be, in order to get that, you'll still visit websites. It's just that the website will be stored on your computer and you could use it on your computer. The language and frameworks which are easiest to learn and which you can build out products the fastest will dominate the market. Web development will come back and overtake application developer jobs. Data entry and repetitive jobs will be eliminated because you'll be able to pull in data just by scanning a sheet of paper. And mobile application jobs will even decline as web technologies improve. Companies that resist, like before, will be taken out of business. I might be wrong, but this seems like the logical progression to me. This leads to our next question. What are the expenses related to hosting a web application? Now, if you plan on hosting a web application that will have many users, there are costs involved that you should know, and you should know where you'll be hit. You pay for the server that stores your web application. You pay for the space your web application takes up. You pay for the domain name. You pay for the network usage. You pay for the software. You pay for the support. And by software, I mean like the web host, any antiviruses, or software that your website uses, especially if they have license. So sometimes in order to use a programming language, you got to pay the creators of the programming language. Not always, but quite often. You pay for the processing power your application needs. So whenever someone goes to the site, that's if you're using the cloud, that they charge you. They'll be automatically, that cost will automatically be charged to your account. Those are the main things. You might be able to think of more, but this is, I figured this was some high yield information that you might be able to use. But something else is the reason often given for using different languages or frameworks for building applications is reduced costs via reduced processing power, reduced software usage fees, reduced network bandwidth utilization, less hardware, and licensing costs. Or ease of integration with other systems, reduced reliance on underlying technologies, the speed at which you could roll out the software. But I find that in the case of software engineers, they rarely state reduced workload or development overhead. They tend to create unnecessarily high amounts of work because there's so few, people that could argue against them because there's such a high demand for that field. So they don't look at, so oftentimes they learn things like SQL out of self-defense, but they make assumptions that that's all there is to it. As a result, they rebuild the wheel a lot of times because they're implementing stuff they learned in school, but don't actually know the details of the language, which is where the time is saved and the cost is saved. But you will after we go through this. So yeah, that's all for now. I figured those were major high yield questions that you need to know the answer to. You might disagree with me, but I believe that knowing these questions come up again and again, and knowing this can get you a job or help you get clients. So yeah, that is all for now. Till next time. I guess this was a long video. The next one should be shorter.